Solving simultaneous equations. Take 1. Method of elimination. Now here's my pair of simultaneous equations to solve. X plus 2y equals 7, and that's equation 1. 4x minus 3y equals 6, and that's equation 2. Now in order to use the method of elimination, I've got to equalise the coefficients of either x or y. It looks easiest to me to equalise the coefficients of x. So I can take equation 1 here and multiply it by 4. So that's what I've got here. So x times 4, 4x, plus 2y times 4 is 8y, equals 7 times 4, 28. I'm calling that equation 3. Now I can eliminate the x's by subtracting. And it looks easiest for me to take equation 3 and subtract equation 2 from it. So that's what I'm doing here. So 4x minus 4x gives me 0. 8y minus 3y is the same as 8y plus 3y. So that's 11y. 28 minus 6 gives me 22. And now I can simply solve this equation and get y equals 2. And there's my first solution. What I do now is I take this solution and substitute it into equation 1. Looks the easiest. So x, the same, plus 2y, well that's 2 times 2 which is 4, equals 7. There we go. So x plus 4 equals 7. I can solve that straight away. X equals 3. So now I've got my two solutions. But because I'm smart, I want to check. Now I got this solution, x equals 3, from equation 1. So when I do my check, I'm going to check in equation 2. So here's equation 2. I'm going to put the values x equals 3 and y equals 2 into this equation and see what happens. So 4x, that's 4 times 3, minus 3y, that's minus 3 times 2, equals 6, equals 6. Let's see, 4 3s are 12, minus 3 times 2 is 6, 12 minus 6 is 6. So yes, that's absolutely right. So all I need to do now is to write my solution set. X equals 3 and y equals 2. Now this time I'm solving the same two equations here, but using the method of substitution. Now this is rather longer in this case, so I haven't actually finished it. I've only gone as far as solving for y. The rest of the solution is exactly the same as the elimination method. So I start off with my two equations, x plus 2y equals 7, equation 1. 4x minus 3y equals 6, and that's equation 2. Now in order to use the substitution method, I've got to write an equation y equals something or x equals something. And I'm going to choose that x equals 7 minus 2y. And that comes from equation 1. I'm calling that equation 3. Now, because I used equation 1 in order to make equation 3, I'm going to substitute equation 3 into equation 2. So instead of writing x, I'm going to write 7 minus 2y. So 4x, that's 4 into 7 minus 2y. Minus 3y equals 6 the same. Now expanding the brackets here, 4 times 7 gives me 28. 4 times minus 2y gives me minus 8y. I've got minus 3y here, so that's the same. Equals 6 the same. So I've got minus 8y and minus 3y. That gives me my minus 11y. And I've got a 28 here, which I subtract. I subtract from this side as well. Gives me minus 22, and when I solve this it gives me y equals 2. What I do with this then is substitute it back probably into equation 1 and continue, and of course I should find that I get exactly the same solutions. And the third method is to solve these two simultaneous equations graphically, and it could hardly be simpler really. All I need to do is to draw the two lines that correspond to these equations. This is the line of 4x minus 3y equals 6, and here's the line of x plus 2y equals 7, and where the two lines intersect at x equals 3 and y equals 2 is my solution set, and that's probably about the simplest way of solving this type of simultaneous equation. Although in this case I would say the lines are a little bit tricky to plot. Anyway, there you go, 3 ways of solving simultaneous equations.